Welcome to the Magical Candle Experiment. Today we will show you how you can do this experiment at home. The following are a list of materials that were required for this experiment. The first item that you will need is a tub filled with water. The second item you will need are matches to light the candle, as well as food coloring, a self-standing candle, and something that can fit over the candle. Here we have shown an Erlenmeyer flask, a beaker, and a bottle of pop.
Step 1. Pour a few drops of food coloring into your tub of water. This will help make the experiment more visible. Step 2. Mix the food coloring using a stir stick. Step 3. Place the candle in the middle of your tub of water. Step 4. Use a match to light the candle. Step 5. Place a beaker or bottle over the candle. Be careful to make sure it stays lit. Step 6. Make your observations. Now that we know what happened, we can go about explaining it. There are two components to this explanation. Let's begin by taking a look at the chemical aspect of this demonstration. Recall that we started with a lit candle, but at the end the candle had gone out. Why might that be? Since our candle is burning, we know that there is a combustion reaction occurring, and the general equation for a combustion reaction is written below. In this demonstration, oxygen and paraffin from the candle are reacting. This burning produces water and carbon dioxide. Looking at the balanced chemical equation, we should notice that twice as much oxygen is burned than carbon dioxide is released. Because of this, the air volume decreases the longer the candle burns. From the ideal gas law, we know that a decreased volume of air means that the pressure inside the beaker has also decreased. Because of this, the air pressure inside the beaker is negative relative to the air pressure outside the beaker. This pressure gradient draws some water up into the beaker. After some time, we see the candle dim and go out. Since there is a fixed amount of air in the beaker, once the oxygen is used up, the flame can no longer sustain itself. At this time, the contents of the beaker is mostly carbon dioxide and water vapor. Now let's consider the physical changes occurring. The candle heats the air around it, and the air expands. When the oxygen is used up, the candle goes out and the air cools down. As the air cools, it contracts. Again, the volume of air decreases, as does the pressure. This acts like a vacuum, sucking up water into the beaker. These physical changes occur towards the end of the demonstration, and are primarily responsible for the rise in water level. Lastly, notice that after the demonstration has concluded, the water level inside the beaker does not fall. This observation confirms that there is both chemistry and physics at work here. If this was just caused by the physics of heating and cooling, we would expect that after the temperature has returned to the starting temperature, the water level would go back to normal. Instead, the water stays high, which confirms that oxygen has been depleted and replaced with half as much carbon dioxide. In the following video, an experimenter recreates a similar experiment, but heats the bottle instead of placing a candle inside of it. They get a similar result, but the water level doesn't rise quite as dramatically. In this case, the water level rise can only be attributed to the physical change and not to the chemistry of a combustion reaction. Thank you for watching our video. We hope you enjoy experimenting with your own magical candle.